Hello everyone, I am Kazi Hassan Safa. Today I will discuss about machine learning assignment 3. This assignment is about convolutional neural network. It is a class of artificial neural network. It has two parts. First part, I will run on the pre-coded cells to see and understand how convolutional 2D kernel works, and at the end, a response to the question 1 and 2. In second part, I will run pre-coded cells to run the given neural networks and then respond the question from 3 to 10. Firstly, I imported necessary libraries. These libraries for part 1. Then I link the image. After that, you can see I plot the image from array. Here I printed array shape. Then I compare value here, channel 0 and 1, and here channel 1 and 2. Again, I plot the image. Now, I will discuss about 2D kernels. Here I create a kernels and compare both arrays. And here I display one tray image. You can see. And now I discuss about standard convolution. Here I define a function. You can see here. If the value is less than 0, then it will return 0. If the value is greater than 0 and less than 255, then return with the value, otherwise return 255. Now I will discuss about line detection. Here I define a kernel. This is 3 by 3 matrix. Then I apply here kernel to the image. Then I plot the resulting gray image. You can see here my image. Now I will discuss about question 1. You can see here. Here I define a 45 kernel. This also 3 by 3 matrix. Then I apply kernel to the image. Then I plot resulting gray image. You can see here my image. Part B, I also did the same thing, but a difference is here 135 degree lines. And this is my image. For question 2, here I take kernels and type my code here. Let's see. And this is my image. This is my image for question 2. Now I imported all necessary libraries for part B. You can see here, and loaded my data set here, and building my neural networks. This is my model, and this is my model summary. Here I displayed 4 layers. First layer is convolution layers. Second is max plotting layers. Third is flattened layers, and fourth is dense layer. Here I created a custom callback class. See here. This is my training the network. training network. Then I plotting my result. You can see this is my result. The blue one is training accuracy, and the red one is validation accuracy. For question 3, yes, the network presented signs of overfitting. It starts from 10th epoch. The blue epoch is shown the overfitting. For question 4, there are 4 layers, and layers are flattened layers, dense layer, max pooling layers, and convolution layers. For question 5, flattened layers the multi-dimensional input tensor into a single dimension. Dense layer is learn global patterns. Convolution layers learn local patterns, and max pooling layer is a pooling operation. For question 7, now I will add more convolution layers to my model and run it again. You can see, and I run it again, and I plotted the result. Here also the same thing. I train accuracy is the blue one, and red one is a validation accuracy. For question 7, here I compared the result of convolution layers and overfitting and describe what are the differences between them. The accuracy increase for the test datasets and validation datasets when increased over convolution layers. On the other hand, overfitting reduced when increased convolution layers. For question 8, you can see here, I added a dropout layers to my model and run it and compare the result with previous one. For question 9, dropout layer is random. Here I explain the purpose of dropout layer and how it works. Dropout layer is to randomly zero out of some of the output feature during training model. Dropout is a technique used to prevent a model from overfitting. It works by randomly setting the outage edges of hidden units to 0 at each update of the training phase. For question 10, here I made another modification in the hyperparameters to improve the model's accuracy and compare the final result with the previous one. You can see here and plot the result. That's all for today. Thank you for watching my video.